World, welcome back to another tutorial. Today we're going to be talking about diffuse lighting with Phong shading. Now, a couple episodes ago I did a Phong shading math concepts video where we talk about the dot product, vector subtraction, normalization, and something else. We cover all those in that video, so I'm not going to be doing, ultra low level, what do those mean? You can go check that out there. And this one's going to be more of a high level concept, and then we're going to dive into the code, which, you can see that low level concept being applied at a high level, whatever. But just so you know, diffuse lighting is one of my favorite topics when it comes to lighting. It was one of the first things that I really made me understand how lighting works in a 3D environment. Basically, if you have an object floating in space and you have a light source somewhere off in wherever land, the fronts of the surfaces of that object that are facing the light should be brighter than the surfaces that are facing away from the light. And that's what the diffuse does. It allows us to apply somewhat realistic lighting to, fake binary zeros and ones, and I think that's super ultra amazing. So I hope you guys like this episode. If you do, hit that thumbs up button, subscribe if you want more content, but let's go, because as you can see, I'm a little excited. Let's roll. Okay, so in the last few episodes we've talked all about this formula you see before you, where we have the intensity of Phong is made up of intensity of ambient plus the intensity of diffuse plus the intensity of specular, and then it comes out to look like this crazy formula you see before you. The last episode that we did, we talked about the ambient intensity aspect of this formula, where it's basically the summation of all the light and material ambient. You go watch that episode if you're interested in how that works. Now, in this episode, we're going to go ahead and add on the diffuse component of the Phong formula. And that looks a little bit like this, where we have the new Phong identifier of diffuse being applied based on L.n. And what is L.n? Well, that's going to be the normal vector and the two-light vector. And once we have the normal vector and the two-light vector, we are able to put together the scalar that is the dot product between those two vectors. So what I mean by scalar is now we can take the KD, which is the material diffuse, multiply it by that dot product scalar, and then multiply that product between those two values times the light intensities, or the light diffuse intensity. So that will produce our diffuse value. Let's do a quick real world example so you know what the hell I'm talking about. Say we have this sphere out somewhere floating in space, and we have a light source, which in this case is the sun, and let's pretend this sun is an infinite distance away from this object. Now on this object we have a bunch of fragments, we have a bunch of things we need to color in. Let's take in maybe this little area. So this area on our sphere has a two-light vector that looks something like this, and you can find this two-light vector by doing vector subtraction between the light data's position and the world position's vector. Now we also have normal vectors all over our object, but in this case it's pointing straight up, which is pointing in the exact same direction as our two-light vector. Now if we take the dot product of these two vectors, we should get a value of 1 because these two vectors are parallel to each other. And we all know that if we have the input material color, say this object is this gray color, and we multiply that by 1, our scalar, our dot product, we should get the exact same output color. So it's going to be pretty bright towards all the surfaces that are facing the light. Now, say we take into consideration these 2 points, where they have totally different normals because their plane is a lot different right there. And we have that two-light vector being applied, which is pretty much exactly the same as it was before. Now this looks more like a 45-degree angle. It's not parallel, it's 45 degrees, which comes out to be about 0.5 if you take the dot product. Now say we have that same material color, now we're multiplying it by the scalar 0.5, we're going to get about half that color back. It's going to be a lot darker. And if we jump down here to where the two-light vector and the normal vector are perpendicular to each other, well, when two vectors are perpendicular to each other, we get 0. We get the value 0 back. And if we multiply our input material color by 0, well, we're going to get, nothing back. It's going to be 0. However, at this point, we do still have our ambient calculation that we did in the last episode, so we should get that color back. Anything lower than 0, so down here we get these negative values. Well, let's just say that anything less than 0, we'll just put it to 0. We're going to max it out to 0. So if we had our material color times any negative number. It doesn't make any sense, so 0 is going to be our output color. And that's it. That's diffuse. It's relatively straightforward. It's easier to show you in code, so let's go back to the code and check it out. Okay, so back on our game engine, we have this purple cruiser, and it's purple because right now we have ambient lighting being applied from the red light and the blue light. But the top of this object should be brighter than the bottom of this object, so it doesn't really look normal, doesn't look right. So let's go ahead and apply diffuse lighting so we get rid of that problem. I'm gonna stop this. I'm gonna jump into graphics, shaders, share.metal. I'm gonna start with the shaders because people who are doing other languages like DirectX or OpenGL, these concepts transfer. If you're watching this, you're like, I don't know metal. It doesn't matter. These are concepts, and you can use these in any language you go into. Just the concepts that are important. So let's start in this share.metal file and go up to our vertex in and add our normal. So float3 normal, I'm going to put that at attribute 3. And that's going to come in from the vertex. Now, if I scroll down to material, I can add float3 diffuse. And in my light data, I can now pass float diffuse intensity. If I scroll up though, from the vertex in, we need to be from the vertex shader, we need to be passing some extra stuff through the rasterizer. So I'm going to add a float3 world position and also a float3 surface normal, because let's explain that. The world position is going to be used for calculating the vector from the world position on the current fragment that we're working on the surface of the object to the light. So we're going to need that world position that gets interpolated in the rasterizer, and then we're going to need that light data position to get that vector pointing towards the light. And the surface normal, if we have two vertices, it's going to get interpolated, which means that normal is going to be interpolated over that value. And so this is going to be the surface normal at the current fragment we're working on. And we're going to send those through the rasterizer data in the vertex shader. Let's go do that. So if we go to basic shaders, up at the top here in the vertex shader, I'm going to create a float4. That's going to be world position. The world position is going to be, if I look over here, it's going to be this calculation right here between the model matrix and position. So I'm going to cut that out. I'm going to go world position, because world position, like we have our position, right? We just have our model space, and then we multiply it by the model matrix, which gives us the world space. Where is it in the world? It's translated, rotated, and scaled. That's why it's called world position. So from here, I'll go rd.worldPosition equals worldPosition.xyz, because this is a float4, and we need the three vertices. It's a vec3 or float3, so we only need the x, y, and z values. And then the second thing I need to return is the surface normal. That's the one that I added on there. So rd.surfaceNormal equals, okay, so say every vertex has a normal, right? If I do not update the normal's positions using the model matrix, because right now our object's rotating, translating, and scaling. If I don't update the normals to rotate, translate, scale with that object, it's going to stay the same no matter what. So what I need to do for the surface normal is I need to multiply modelConstants.modelMatrix times, I got to cast it to a float4, vIn.normal. Let's make the w-axis 1.0. And then since the surface normal is of float3, I need to return x, y, z. So now our normals are also going to be rotated, translated, and scaled alongside of the position of our vertices. Now we're done with the vertex shader. Let's jump into the fragment shader. Specifically, if I scroll down to if material is lit, we're going to do the lighting calculation. Currently, we have a total ambient that we're summating. We're kind of just adding the light data and material data to this total ambient. And at the end here, we're setting Phong intensity equal to total ambient. If I remove this comment and that semicolon and just move that semicolon to the end, now the Phong intensity will be made up of total ambient and total diffuse, just like I've been saying this whole time. But we don't have a total diffuse variable. So up here at the top, I'm going to create a float3. Total diffuse equals float3, and I'm going to instantiate that to nothingness. We don't need any total diffuse to start off with. Inside the for loop now, we can do the diffuse calculation, so diffuse lighting. I'm going to type some stuff out real quick, and then I'll come back to this in just a second. I'll be back. back in to non-fast forward mode, the first thing in this diffuse lighting calculation that I added was the unitNormal. Anything with unit in front of the variable, I've normalized. And if you don't know what that means, go back to that math concepts, the Phong shading math concepts video. I talk all about normalization. So I'm creating the unitNormal. I'm normalizing the surface normal, because what if that value, the length of that normal is not 1? We want it to equal 1, so I'm going to normalize that unitNormal first. The second thing I need to do is create the nDotL. Like I said in that math concepts video, if I need to get from the world position to the light position, I need to subtract the position of the light, the head, minus the tail, gives me this arrow. So I need to get from the world position to the light's position, so I'm going to subtract these two. And that'll give me the vector that points from my current fragment position to the light. Then I go ahead and create this diffuseness equals material.diffuse times lightData.diffuse intensity. Just like with ambientness, I did the same thing there. It's just getting that diffuse. How much diffuse are we actually adding to this thing? Then I added this nDotL. This is the dot product of nDotL, so I called it nDotL. It's pretty nice, right? I've seen that other places. It's not unique to my code. But that's going to be a scalar, so I'm going to return a float. And that's going to just be the dot product between the unitNormal, so that's going to be n, and then I'm going to do dot, and the toLightVector is L, so nDotL. Pretty cool, right? And then I'm going to take this nDotL and this diffuseness, multiply them together to get a final diffuse product, and then I'm going to multiply it by the light color so that I can get a diffuse with that light color applied to it. So if I'm shining on top of an object, it'll come out with that color and not, white. And then I summate, add to that total diffuse up at the top, the diffuse color that I finally calculated. And that's the calculation. There's a couple modifications that we need to make though. And the first one's going to be the dot product, nDotL. This value right here returns a value between -1 and +1. So what I'm going to do is before the dot, I'm going to call max. And at the end, I'm just going to add a 0.0. And what that's going to do is it's going to return, if this value is less than 0, it's just going to return 0. That's what max does. It returns the maximum value between these two numbers. The second thing I need to do is for the diffuse color, because this could return technically a negative color or something over 1. So what you can do is you can call clamp, which you can clamp this value between 0.0 and 1.0. Because we don't really want, let's get rid of that semicolon. We don't really want this value to be less than or greater than 1 or 0. Like we don't want this to be 400. It doesn't make any sense because 1 is the maximum value. And then we summate that, 0 to 1 value. Just like we did this clamp down here, we also need to do it on our ambient color. I totally forgot to do that. And one other thing is at the end of here, after lightData.color, I need to go lightData.brightness. Because this needs to take into consideration the light data brightness. And I'm going to copy this and go up to ambient color, paste this right there because I didn't do it there either. Now let's clean this up just a tad. This unitNormal, right now I'm calculating it for every single light. We do not need to do that. I can take this and move it to the top of this function inside of this material is lit. I can move the unitNormal up here, and then this unitToLightVector, I might need that at some other, I don't know. I'm going to put it up at the top here so that I'm doing all my calculations for these values down here at the top of this function. And now we just go up to the ambient color, do clamp between 0 and 1. That looks good. That is our diffuse. That's diffuse. We've implemented diffuse into our fragment shader, and I'll show you the whole fragment shader just because it looks beautiful. So navigating out of the GPU code or the shader code, I'm going to go into core types, metal types, to update the types that we're sending along to the GPU to match those shaders.metal file. The first one I'm going to start with is Vertex. So I'm going to create the var normal like we did in the GPU side. I'm going to scroll down to material. We're going to create var diffuse, which is a float 3. I'm going to set that equal to a float 3 of 1, 1, 1. So it's just going to be a scalar of 1 for x, y, and z. And then down here, I'm going to go diffuse intensity I'm going to set that equal to a float, which equals 1.0. Now I'm going to modify the ambient to be 0.03, and you'll see why once like we go into it. It won't even be 0.03. Let's just do 0.1. Let's make it just a little darker so that ambientness is darker when we first start up our if we make like a default object. But yeah, this is going to be our metal types. Let's go into entities, libraries, mesh library, and we're going to scroll down into the custom mesh where we have this add vertex. Anytime we make a custom mesh and we add vertices, we call add vertex, and that creates this vertex. However, we don't have a normal applied to this vertex yet, so we need to add a normal onto here. In the parameter list, I'm going to create normal, and that will be a float 3, and I'm going to set that equal to float 3 on 0, 1, 0. Basically, I'm just creating a default value that points up on the y-axis, just straight up. And then at the end of this append for the vertex, I'm going to create normal, normal. And I'm going to return these down so it looks a little cleaner because it's getting a little long. And we should see now that add vertex builds just fine. If I scroll up on this file up to model mesh, right now we're reading in the position, the color, and the texture coordinate from our model file. But if I were to go to res sphere and open as source code, I've already opened it here, but if you scroll down to, I guess, line 30,000, this is a normal. Anything that says vIn is a normal, and it's not currently reading those in because we haven't actually defined them in our mesh library model mesh loading function. So we need to go down into this descriptor, and add at the attribute 3, we're going to load the normal. So we need to just put a 3 there and then say that's going to equal the MDL vertex attribute normal. Now it knows to read in from that file all the VNs, which is the normals. Since this model IO vertex descriptor is based off this vertex descriptor, we need to go into graphics, libraries, vertex descriptor library, because our vertex descriptor has no idea what the hell it looks like right now. Let's copy this line, put it down here, and this is going to be our normal sizing of our vertex layout. So this is a float 3. It's going to be an attribute 3. The buffer index is still going to be 0, but the offset is going to be offset now. It's 3 plus 4 right here plus 2 now. So I need plus 3 plus 4 plus float 2 dot size. If I were to press play right now, I think everything should work. Now I'm just too excited and I want it to work. So if I'm gonna press play, oh, look at that, we have lighting. Oh my gosh. So now there should be diffuse lighting on our object and it looks pretty cool. See, the bottom's a lot darker than the top and it looks freaking fantastic. Let's go and update our CPU side code to be able to, like our engine code, to be able to modify these values. So what I'm going to do is I'm going to go into game shiz. Let's go into game objects, game object, and down at the bottom in this extension, I'm going to copy this whole ambient bit of code and paste it right underneath it. And now we're going to do this for the diffuse because it's pretty much exactly the same. And instead of calling sets and gets on material ambient, if you hold Alt and drag, you can update all of these at the same time. So this is now going to be diffuse. This is, I'll just copy this, paste it right there, right there, right there. Oh, diffuse, 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 diffuse. Let's jump into the light object. Copy this right here, the ambient intensity, and do the exact same thing because now this is going to be the diffuse intensity. And this is going to update the diffuse intensity. Oh, diffuse intensity. Oh, I didn't update my light data's function call, so this needs to now be diffuse intensity. Gorgeous, gorgeous. Go back into game shiz, go to scenes, go to sandbox scene, and let's just update the cruiser. So we're going to go cruiser.set ambient, material ambient, to be a float value that's pretty freaking low, like 0.01. Because if we eliminate all the material ambient, the intensity of the ambient is now going to be 0.01. It's almost not even there. But you'll only be able to see the diffuse value on top of our object. Isn't that cool? And you see from both sides, this side has the blue, this side has, this side's kind of white, and this side's red. So it's taking into consideration all those values, and it's so cool looking. So just to kind of change it up a little bit, let's make this, let's make this 0.01. I guess that makes a little more sense. And then I'm gonna go down here to the do update and just kind of add a little bit of code just to have some fun. I'm gonna say left sun dot, let's say set position x. We're gonna update the x value to be the cosine of, let's go game time dot total game time. So it's just gonna move left and right. That's all it's doing. And we're gonna do the same thing for the middle sun and the right sun. So I'm gonna copy that and just throw it right there because I'm lazy, and I'll just type this one out because I want to. So now we have left sun, middle sun. Since we're updating the x to be exactly the same, let's go left sun is gonna go -1. So whatever cosine value gets returned, we're gonna subtract 1 from it. So it'll move it over 1. Not do anything with the middle sun. And then we're gonna increase this one by 1. The last thing I want to do is just say middle sun dot set brightness, material bright or light brightness to 0. I don't know. Let's go 30%. So it's not going to be as bright. I just don't want it as bright because there's a blue light and a red light, and I want those to kind of stand out, but I still want there to be some sort of a lighting with the white. And oh man, does that look good. So, I hope you guys enjoyed this episode. If you liked it, hit that thumbs up button. If you want more content like this, subscribe. Let me know what you want. Give me some suggestions because, you know, at some point I might run out of things to talk about. And yeah, I hope you guys enjoyed this. See ya.